welcome to another electrifying episode of Math and Silly Hats. Today we'll be looking at analyzing relations between points, lines, and planes when given a figure. Now this is a lot of information, so we're going to break it down step by step. The first thing we need to know before we do anything with this giant figure with lots of little parts is understand what those parts are and how to name them. So we're going to go over here and we're looking at the definitions of these different points, lines, and planes, parts of the figure. So a point is a singular location in space, just a single point, zero-dimensional. And we name them point and then the capital letter that is next to that point. Next we have lines. This is an infinite number of points arranged in one-dimensional space, so only length. And it extends forever in both directions at the end of that line. So if we see what looks like a line with two arrows at the end, this is important to distinguish it between a line segment or a ray. A line will have two arrows, one extending on each end to represent that it goes on forever to infinity. So we see three capital letters, A, B, and C. Now we can name a line by naming any 2 points on that line, such as A and B, and drawing a line symbol above it. Or B and C with the line symbol above it. Or C and A, or any order of those 2 letters. Now, importantly, when we name it with the points, we will capitalize those letters just like we did when we named the points. So if we name it with these points A, B, and C, we're going to use capital letters A, B, and or C with a line symbol above them. There's one other way to name a line. If it's labeled with a lowercase letter, we can just name it line and that lowercase letter. That's the only time we'll see lowercase letters in these figures. Finally, we have planes. Planes are a flat two-dimensional surface, so they have length and width, like a piece of paper, but they also extend forever in all directions. So here's our example. They're always represented almost like a three-dimensional piece of paper, but it's important to understand that this could go on in all directions forever. So we see points D, E, and F on this plane. And we can name it plane and then any 3 letters that are not in a line together. So 3 points that would necessitate that a plane be drawn across them. The other way of naming planes is if we see this script, this fancy looking uppercase P. It's the only time we'll see that. It can just be plane or that uppercase script P. So whatever letter represents that plane, it'll look distinct. We'll only see that when we reference planes. Last 2 terms we need to know are collinear and coplanar. Just like co-education, co-ed, when we have boys and girls mixed together in either a sport or a gym. Collinear means we're going to have multiple points on the same line. Coplanar will mean we'll have multiple points or lines on the same plane. Now that we've gone through the definitions, let's look at our first example. We have a lot of information here, and we're going to be asked a lot about it. So let's take this one step at a time. Here, I'll notice I have, first, working large to small, a large plane. That's this 3D piece of paper looking object. It's called Z, with that fancy looking Z. That indicates that that's the name of a plane. Or I could name it any 3 points that would require it be a plane. I cannot name this plane MNP, because that could be a line or another plane that came out of the board. So it has to be 3 non-collinear points. If I'm asked to name this plane, I could name it using any of these 3 points that aren't on the same line. So L, M, J would work. L, N, P would work, but I cannot use plane MNP. Next, I have a line. Well, I have 2 lines. I have a line going through this plane, almost like a piece of paper that's had a pencil stuck through it. You can see this part of the line extending through this plane, and then there's a part behind the plane going back into space. So line HJ is extending through or piercing that plane. We also have another line. Line MN is on the plane. So points MN and P are coplanar, as well as this line MN is coplanar. Now, as far as just single points, we have many points, right? 1, 2, 3, 4, 5, 6, 7 points. Notice this is not a point since that fancy Z, that script, that's going to be the name of the plane. So we have 7 points, and we could make lines or planes with any of those points. Now, what we're going to be asked about this, I've listed a few of the questions we could see about this figure. Suppose we have a line, LK. Now, obviously, line LK is not on here. It would ask us, then, line LK and something are distinct intersecting lines. So we know that whatever goes here is going to have to be a line. Lines are named either with 2 capital letters and a line symbol above them, or with the lowercase letter. Since we don't see any lowercase letters here, we can't use that naming schema. So we're going to have to write 2 uppercase letters that represent points and a line symbol. Now, thankfully, ALEKS gives us a hint here because our question gives us an example of naming a line using 2 uppercase letters that represent points and the line symbol to know we're talking about a line. Suppose line LK is drawn. Well, let's draw line LK. Now it asks me, line LK and some other line are distinct intersecting lines. Now, there's one line I see that I don't want to use. MN, this line up here, looks like it's almost parallel to LK. So I wouldn't want to list that as a line that intersects because I don't see it intersecting, and it could be the case that they never intersect. However, if we look at point K is clearly an intersection between this green line, LK, and this black line. We could call this JK lol. So line JK certainly intersects line LK because they both intersect at point K. So let's use, for this example, line JK. Again, we're going to name it with those 2 points as uppercase letters and a line symbol above it. So line LK and JK are distinct intersecting lines. The next type of question we could have is to name plane Z. Again, they kind of give us a hint. This is not a point. It's part of the naming schema for this plane. So they've chosen to name this plane with just the script letter. So we have to name this plane another way. Now, to name that plane, we could also use 1, 2, 3 points that are not collinear on the plane. So to name plane Z, I could name this any of these points on the plane that are non-collinear. I cannot use point K or H since they aren't on plane Z. So I'm just going to choose 3 non-collinear points, M, J, and L. Now this is obvious that M, J, and L don't form a line, so I'm allowed to use those to name this plane. So I will just use points M, J, and L. M, J, and L. To make sure that those would make a plane, we could try connecting these with a line, but we see if I draw the line this way through LJ, I won't hit M. If I draw the line this way through JM, I won't hit L. So we know these are not collinear. So these are 3 coplanar points that are non-collinear, and we can use M, J, L to name this plane Z. Next, we could be asked, something and N are distinct collinear points. Well, we just see a uppercase letter here, N. That is how we name points, with just their uppercase letter. So this gives us a hint that this needs to be a point. So we want them to be distinct, they can't be the same. Collinear, they have to lie on the same line, points. So we need a point that's on the same line as N that isn't N. So if we look up here, I can see a lot of points on this line. Let's use that since it's there. So M and P are both collinear with N. So let's use point M, since these are certainly collinear. If we're asked for multiple points, we could choose both M and P. Since all of those lie on the same line, that means they are collinear. Finally, point L and line something are coplanar. So that means they lie on the same plane. point L, so we're talking about this point here, and a line. So we're going to have to use that same notation we used earlier, the line symbol with 2 points below it. So I'm going to start that. Let's go back to that figure. Let me clean that up. Much better. Now I need to find a line that is coplanar with point L. So if I look at point L is on plane Z. So I need a line that is also on plane Z. Well, if we look at HJ or JK, they're the same line and they go through that plane, so they're not coplanar. They're piercing that plane. However, I do see another line that is on plane Z with L. The line up here, MN or NP or MP, this is a line that is coplanar with point L because they're on the same plane. So we're going to name this as a line. We need that line symbol above any of these 2 points. So I'll choose M and N. So line MN is coplanar with point L since they both lie on plane Z. Now there's lots of questions you could be asked about these types of figures, and each of them is going to have their own complexities. But if you go back to your base definitions of point, line, plane, and what it means to be collinear, lying on the same line, or coplanar, lying on the same plane, hopefully you can be super effective at solving these problems. Have a great day, everybody. Bye-bye!